unified logging system. This is not the whole picture, but it gives you, I think, a good overview. So we have many sources on the left, for example, so application that comes from the services itself or from the machine, which we forward with fluently to a Kinesis stream. And we do that very similar for other kind of information like ERP-logs, which is the local ones in AWS, CloudFront is the CDN, and a lot of other logs. And it's basically always the same pattern. We have different Kinesis streams where you can put in the data. Kinesis provides 7 days until the data gets deleted, and at the other end, it's like a queue basically. And at the other end, we have a Lambda running, which forwards all the data and puts some of the data in a sugar bucket for long time storage. But also everything goes into our Elasticsearch cluster, so that we want to have an overview, want to have a look on all the data for the last 9 days. That is our requirement. And yeah, that's what we're talking about Elasticsearch, and also how it fits into our principles. With the project Tetsu, we also came up with these principles. They evolved after some time, and yeah, you can don't see everything. I provide then the link also to the slides. There's also the link to the GitHub repository where you can find these principles. And I want to pick up one essential one that is now important for us, which says infrastructure as code. So it says automate everything, reproducible, traceable, and tested, immutable servers over Snowflake servers. So this also implies that you can do also a continuous delivery or continuous deployment. And at first sight, I think it sounds good, right? And the good thing is that all our new services apply to that principle. Every infrastructure they have on AWS is based on some configuration files, and there are actually no manual changes. The thing is that we actually get alarms if you do some manual changes. And when you think about microservices and web applications or web services, it sounds not that complicated, because web applications often, especially when you can do for start from beginning, they don't have any state, or you can avoid that. But in our case with Elasticsearch, we have data, and we have to handle that. And here are some numbers what we're talking about, which is the current setup. A couple of days ago, we run currently 12 nodes, which has 2 terabyte storage attached. We have 9 indices for every day. It's a separate index, and yeah, we split it up in 36 shards per index, and in total, yeah, we have 7 billion documents there, and the peak is about 2,500 new documents per second. It started not like that. We started with about 20 gigabytes per day per index. We have now, I think, roughly 1 terabyte on data per day.
Are these 17 terabytes including our replicas?
Yeah, we have 1 replica set, so yeah. Yeah, again, how can we handle the state? First of all, we are used to have immutable servers. As I said earlier, it was a big principle, and we started everything like that. So also when we started with Elasticsearch and that solution, we said also we want to have immutable servers because it gives us atomic deployments. It's repeatable. You can do that again and again, get the same results. You can recover fast, And it gives you also the possibility to experiment. So you can set up the whole thing again and then again and again, just a matter of cost on the AWS side. And what we have here is a setup of 3 things. So we have a wake file, which has basically 2 tasks. We first build our application or our setup. That means we combine all the configuration files, the wake file, also the CloudFormation is build artifact, and store that on S3. And then the deploy task, where we do the deployment, the actual deployment, and there's also some orchestration which we see then later. A second part is CloudFormation. How many of you know what CloudFormation is? Not many. CloudFormation is a service from AWS which creates the AWS resources for you. It creates autoscaling group, load balancers, EC2 instances, and this happens based on a configuration file. It's a JSON, somehow every JSON configuration file, and you define the desired set that you want to have. You give that to the CloudFormation service, and CloudFormation creates or updates or does the changes that needs to be done. So we have in that CloudFormation we have an autoscaling group which creates our EC2 instances, as our actual servers. We have defined an EBS volume, our storage. And when these EC2 instances gets created during the startup, we install Elasticsearch, we install the plugins, we copy the configuration files from the build artifact, and deploy then also the template mappings that are also defined in the configuration. And that brings us to the last one. So also the Elasticsearch configuration is in our code report, is in our code and in our repository. So we have the Elasticsearch YAML file where we have a cluster name and also the settings for the discovery, because you need the AWS plugin for the discovery. We have the mapping defined in an index template, and we have also the login configuration in a separate file. And that's, of course, we want to have continuous deployment because it gives us fast feedback. We learned that in the past, the faster we can release, the better it is for us. We see the results of our changes immediately, as fast as possible. And that's also something where we can reduce our risk, and we avoid what I call deployment debt. So everything that we don't immediately deploy, it pays in deployment debt. And at some point you have to release it, and the more you have to release, the bigger the risk it is. So we prefer small changes and more frequently. And that's what we also do here. So the setup here is maybe a bit different to our other services that we have. So we have for each node that we have in our Elasticsearch cluster, we have our own CloudFormation stack. So we use the same template, the same configuration file, but they get different names, so 1, 2, 3, 4, and so forth. And that orchestration is then done in the wake file, so we loop over each one and apply the update. And what always also is very interesting, I think, that every commit goes automatically into production. What happens in the deployment? I think everything is on the screen. Is that we check first if the state is green. And green means not only the status that you get from the cluster health endpoint, but we check also for initializing shards and relocating shards. Both has to be 0. We don't want to have any moving parts inside the cluster. And we wait until this is until we get that state, and then we go forward and disable the shard allocation and rebalancing, and then tell the autoscaling group to have, say, we want to have only 0 instances, which means it terminates the EC2 instance and takes node off. When this is done, then we can update the stack, apply our changes, and we wait until this instance get started and is available in the cluster. And when this is done, then we make the shard allocation again and also the rebalancing, and then the same starts again for the next node. Yeah, and the important thing is, that we again wait until everything is green. The thing is that of course we have a lot of state, and Elasticsearch itself can handle the situation that you take off a node and maybe put another node, a new node. But the thing is, it takes a while, and when you remember the data that we have, it would start the replication again and the resharding, and it would take a while until we get another green state without any moving shards. So we decided to use EBS volumes, which is in the storage from AWS, which you can attach to the instance, because it makes us faster. So we keep the data, we just replace the node with the server, but we keep the data and attach them to the new instance. That has the advantage that we don't have to, that this data doesn't have to be copied again. They are already there. Maybe they are a bit out of sync, depends on the load, but most of the data are already here. And the good thing is that we don't put any additional load to the cluster, because if you start with a new one with a new storage as well, then it would take a lot of, not only a lot of time, but put also a lot of load to the cluster to synchronize the data again. And we want to avoid that. So what happens is we have these two instances and the attached EBS volume. And when we say, or when these two instances gets the signal to terminate, it starts to detach the EBS volume, and sometimes the AWS volume is without any attached EC2 instance. And then we apply the update, and a new instance gets created with the new configuration, with new changes, and it gets attached to the current EBS volume. Next thing is what we do with monitoring. We do with two different setups. First, we use CloudWatch, which is also an AWS service, and we have also a Lambda, which gets triggered every minute automatically, and we load all the data, all the metrics that you get from the cluster health endpoint, and put these numbers into CloudWatch. In CloudWatch, you get then it's like a time series. And it gets stored for, I think, 40 days. And then it's very easy to attach alarms based on these metrics. So we have then alarms when the disk space is high enough, or the percentage of usage, and also the percentage of CPU utilization and so on. So you can, for each of these metrics, you can easily set up any alarms. What then gets triggered is the recent what we call Obsgenie, which then calls us full. And if you need more details, if we want to look into some, if you have to invest a problem or something else, we have also Datadog installed, so you can install a Datadog agent. Where you can also get predefined settings, which forwards all the things also to Datadog itself. They provide also a default dashboard, which covers most of the important things, but you can adjust that, and then you can also go back in time and see how what actually happened. Some challenges that we did not solve yet is, for example, the problem with the availability zones. Availability zones in AWS are like different data centers. They are in the same region, for example, Ireland or Frankfurt, but they are completely isolated from each other. And the thing is, availability zone itself normally does not, of course. I don't know when it happened. I think it happened once. But it can go down in your service or your application should handle that. Currently we use only one availability zone. So when this one gets affected, also the cluster gets affected. And our idea is to use the awareness in Elasticsearch itself. You can still find the WAC ID so that the shard gets distributed over the different availability zones. And the thing is, we have to do that manually because we have different stacks, so we have to say each stack in which availability zone it has to run. I think that's should be a big challenge, needs to be done, so that we have done also availability zone awareness. Another thing that hit us was a mapping issue, and we started with 1.6, and I think in our article we were pretty new to Elasticsearch at the time, and it was not visible at the first moment because you couldn't put any data in it, and Elasticsearch would accept that. You don't realize that you have maybe some mapping conflicts, and when we upgraded to the latest version to 3, I think it's a common problem, and then we realized it as well. And if you can remember, we have a lot of different sources where we get the data from, and we have only about a few of them under our own control. And we can then maybe adjust the format or so, but most of them are defined by, for example, AWS or other services, so we cannot change that. So we have, for our cluster, a dynamic mapping. So the first event that gets after midnight gets in, defines then the mapping. And we had some problems, luckily not so many. And the good thing was that it was most of them was the application event that was sent by our own application, so we could go to the teams, talk to them, or please, can you maybe rename the name of that event or that field, so that we don't get any conflict, because now with the do.x you cannot store them anymore, they get rejected. Our idea is to improve that further is to have an index per day and per time. We get a lot of different indexes because we have a lot of different types, but I think it needs to be tested. And if any one of you has any feedback or good ideas, I would love to hear that. And another one is that we still think our deployment takes too long. We have it's based on the number of nodes. Currently we have 9 nodes, and we have a minimum time of 10 minutes until we can replace one node. That's the optimum. And so we have already 5 minutes until we can shut down one EC2 instance, and we have to wait until it's terminated, so that AWS release the EBS volume, and then we can start the new EC2 instance, and then the EBS volume gets attached again automatically by AWS. So, and then we get also a lot of documents in the meantime, so the shards run for the current index, they run out of sync. And that's where we're not so sure why it then takes some time because it takes sometimes only 5 minutes to initialize the shards again, and there's most of the time no relocating, but sometimes it takes up to 45 to 50 minutes until he initializes all the shards, and then it starts relocating for some reason. So we're not sure how to fix that. What we expect is if we shorten the downtime in maybe a couple of seconds instead of minutes, I think that we then can have also faster deployments.
So this is deployments of like new Elasticsearch release, or what kind of deployments?
Basically every code change. Can be some let me see. Can we see what we do sometimes is we use different EC2 instance types. Then yeah, so with that we think we have now the N3 or M4 instances, and we are trying out if small instances are maybe better, or bigger instances getting better. The number of nodes can be adjusted. Yeah, but also upgrades from Elasticsearch itself. So that's the idea. Because when you see the less it takes to replace a node, the faster it recovers. So that we are looking for a solution now to have a very short downtime. So that's that basically. And you can almost see the URL of the I think it's an E. Where I posted the slide, and I think you can also post it in the Meetup as a comment. So if you have any questions, I think you can ask. Yeah.
And do you have a copy of the data somewhere else but in Elastic?
Partially. Because we saw that from the sources, some of the data we get, where we take from some S3 bucket, we keep them there as well. And the data that we don't have on an S3 bucket, we also store in addition to an S3 bucket for long-term storage. So this is the Elasticsearch cluster. This is why it's not that big problem to have only that it runs only in one availability zone, because it's just the data of the last 9 days, and it's not the single source of truth.
How long does it take you to rebuild the cluster if it would just disappear from that data?
It would take one click, and when it starts from scratch, I think you are done in 20-30 minutes.
16
Sorry?
16 terabytes.
No, when everything is lost. When you start from scratch, then it would take, to set up the Elasticsearch cluster, it would take, I think, 20-30 minutes until he creates all the instances again, and then Lambda will start filling in the new data. But if you have a complete loss, then also the data is lost, but as it's just a copy of our S3 buckets, it's not that critical.
Actually, I meant to restore those 9 days that are currently in Elastic. The 9 days of data.
So we mean if we had a data loss?
Yeah, so assume the Elasticsearch cluster just went south. Yeah, all data is lost from it, and you have to rebuild it for the 9 days. How long would that take?
This is a scenario that we don't cover. So we don't have that that use case that we have to rebuild it for the last 9 days. As it would be not nice, but I think we could live with that. But we don't expect a failure, because we at that point we trust also AWS that they can keep the data on the AWS streams. I think it can happen that you have a human mistake and delete something, but as we do normally only automated releases, I think this is not a very likely use case. Does that answer the question?
Yep.
Can you go back to the diagram you had at the beginning, like how the data flows?
The very first one.
Yeah, exactly. I was just wondering.
This one?
Yeah, exactly. What exactly are you using AWS Lambda on the almost right side for there? Is it just kind of deciding where the data should go to Elasticsearch or the event hubs thing?
Yeah, you have to get data out of the Kinesis tools.
Okay, so the lambda is reading from kinesis and kind of just
Yeah,
forwarding.
it's actually pushed from kinesis. So when we arrive in kinesis, they are forwarded to the lambda and then lambda is
Isn't this kind of expensive because you pay lambda for each processing?
You pay lambda
But it's processing
time. Yeah,
Yeah.
18 seconds. The lambda cost is not the one that I cannot give you the actual number, but we can check the maybe later.
It just means that you have kind of, if your data increases, also your price for just forwarding the data from kinesis to Elasticsearch or storage.
Of course. Also we have maybe a scale of these so that they can handle more data. Of course, yeah.
What's the throughput for the system? Around how many documents per second do you?
We have 2,500 documents per second in peak.
Average. Okay.
I think average is something between 50 and 2,000.
But it's just log lines, like it's not big data, like kilobytes or.
A single event, no.
Do you have any experience how to increase that, or what made the most, what had the most impact? Increasing or limiting? Do you have any experience with that?
We hit, actually was an internal limit in kinesis in lambda. We were wondering why we did not get the throughput because the Elasticsearch cluster was not idle, but not a big, had not a high performance. And somehow the data got stuck in the kinesis stream. And then we found out there was an internal AWS link that they used for us. I think they could increase in each other.
So you have more concurrent lambda connections than the average customer. Because this is limited to 100 or has it increased to 500 or anything like that?
I don't know the actual number. They did not tell us much about that limit. But what you get is with kinesis, it depends on the number of shards. You get also parallel executing lambdas. So that's also something how you can scale the execution of the lambda by adding or increasing the shards in kinesis. Even if you don't need